This is a fully functional, almost entirely 3D printed vending machine. It can connect to the internet and is controlled entirely from your phone. It holds 6 different products, even if they're different sizes or weird shapes, and it accepts Venmo payments. I'm calling it the PopVend. So how does it work? My first instinct was to do this the classic way, using vending machine coils like any vending machine would. That turned out to be a mistake. After a lot of trial and error with coil designs and print settings, I did get something that sort of worked, but they were hard to print, unreliable, and products either jammed or randomly fell out of the coils and just bounced on top. So I scrapped that idea. What I use now is a screw and bolt system. A small servo motor turns a set of printed bolts, which push a panel at the back of each shelf forward. That panel gently shoves the product off the edge. Simple and reliable. It does cost a little extra vertical space on the shelves, but the trade-off is huge. The parts print faster and cleaner, loading is easier, it accommodates a much more diverse set of products, and when it's loaded correctly, the failure rate is basically zero. The only issue I've seen is occasional jamming when the bolts are fresh off the printer and they haven't been broken in yet, but that's an easy problem to deal with. This part was surprisingly painless, and that's because of these little guys. This is an infrared brake beam sensor, and it might be my favorite electronic component to work with. They work by shooting an invisible beam from an emitter to a receiver. If anything breaks that beam, even for a split second, the microcontroller knows immediately. They're super cheap, simple to wire, they work practically instantly, and they're very reliable. I put 3 of them at the bottom of the drop chute, and the moment a product falls through, the machine knows the vend was successful and stops the cycle cleanly. There's only one small downside to these sensors. They don't work well with shiny or reflective objects. Which brings me to the trickiest part of the project. Figuring out how to load the machine easily was way harder than I expected. I wanted PopVend to handle almost anything, awkward shapes, tiny items, slippery packaging, as long as it fit into the machine. But now I also had these spinning bolts, fall detection, and shiny objects to worry about. So I needed something that prevented jams, worked with any product, and triggered the sensors every time, and also didn't add a whole lot of complexity for the machine managers to deal with. This is what I landed on. I call them vendisters, or vending frames. They're small, cheap, fully printable, and each one acts like a little sled that the product sits on, letting it glide cleanly over the bolts. On the back, I put a thin piece of cardstock that guarantees the brake beam sensors get triggered, even if the product itself is reflective. They're also quite customizable. You can print longer trays for longer items, and slot-style frames for stickers, pins, or flat items that sit directly on the card backing. They work pretty well. They're not exactly beautiful, and you do technically need 1 per item, which can get a little bit overwhelming. The good news is that in real-world testing, customers are happy to leave the frames behind, so I don't need to reprint them constantly. There's also nothing currently stopping them from sliding out if the machine gets bumped or tilted. This hasn't caused any problems yet, but it's definitely something I would fix before calling this production ready. Another unexpected loading challenge came from switching to the bolt screw mechanism. That panel that pushes the product out of the shelf now needed to be retractable so that the managers could load the machine. It's easy to do this just by reversing the motor, but the harder problem was knowing when to stop. In the end, I added a push button at the back of each shelf. When the panel retracts fully, it presses the switch, signaling that it's reached the limit. It works, and all the manager has to do is hit load in the admin UI and wait for the shelf to retract. But it's another downside of the bolt screw approach. More wiring, more complexity. This is the part that I actually enjoy. PopVend connects to Wi-Fi and opens a live socket connection to a server. When a customer scans the QR code on the front, they're taken to a website where they enter the machine's code. Once that happens, the machine is live. They see a simple interface showing the items available for that specific machine. When they tap an item, the machine responds by flashing a light on the corresponding shelf. From there, you just tap select, choose a payment option, complete the payment, the shelf vends, and the product drops. There are no apps to install, no accounts to create, no confusing steps for the customer. The admin interface looks very similar to the customer UI, but it lets the operators set item names and prices per shelf, update everything instantly, and view sales data and failed vend attempts. It's simple, fast, and built to be adjusted on the fly. This started as an experiment testing the limits of a 3D printer. I was interested in exploring what happens when you combine 3D printed mechanics with electronics and web software. It turned into something that was surprisingly reliable, flexible, and genuinely fun for people to use. In the stores I've been testing it, there's a certain kind of person who really lights up the moment they realize what it is. For them, the machine becomes an experience that brightens their day. But some people don't quite get it, and that's okay too. It's not perfect, but it works, and it's already being tested in stores, and that's incredibly satisfying.